have a scenario where I am being asked to identify the percentage of students when 400 boys are being asked to survey and 140 responded that soccer was their favorite. I need to be able to identify what percentage of boys that represents. I could set this up as a proportion, and I could put 400 as my total and 140 as my part. And when I convert that into a number over 100, I will be able to calculate my percent. That is the mathematical way of doing that. But for our students that need a conceptual representation, I would like to model for you how percentage bars would work. Now on the percentage bars, you can see that I have 0% to 100%. This bar equals 100%, or it represents 100%. That would be true for the bar above it. I have 0 students and my total students is 400. So 400 actual students represents 100% of the students surveyed. Now I am looking for what 140 represents. So the best way to do that is to take the percentage bar into sections so I can correlate them with the actual students. I'm looking for the number that divides easily into both 100 and 400. And a number that does that is 20. So I'm going to simply drag up all of the 20s until they fill up the percentage bar. Now when I count how many I've actually added, you can see I have 1, 2, 3, 4, and 5. So if I divide 5 into 100, I get 20% increments. So if I do 5 into 100, I need to do the same with the 400. So I'm going to draw that to represent that. So I have 5 sections up here, and if I divide 5 into 400, each one of those sections is now worth 80. So that means for every 20%, I have 80 actual students. Now you can see over here, I'm looking for 140 of those students to represent soccer. Now if I look at 2 of my sections, that is 160 actual students, and that is too many. So I know that I'm looking for something that is going to include all of one of these sections and part of another. And that's why I have additional little manipulatives I can drag up. So if I take the 10% and divide the 20 into half, so when I divide 20 into 2 sections, each one of those sections is now worth 10% each. That means I need to do the same for that section above it as well. So I'm going to change color so I can represent this. Now, so this 80 is now, if I split the 80 in half, just like I did the 20%, that means each one of those 80s now become 40. Now, when I add up these 2 sections, because remember, I want to know how many this is going to represent in percentages. So if 40 plus 80 is 120, that's still not enough students. That means I am now going to split one of the 10% in half to see what I get. So let's model that again. So I take the 10%, and now I divided the 10% into a half, which means I need to do the same for the section above. I'm going to change my colors again. So I'm going to go to red so it matches. And I'm going to scribble out that 40. So if I take the 40 and divide that into half, that means each one of these sections is now 20. Ooh, yeah, that's not very clear. Let's give it another shot. I'm going to make that a little narrower. So I have 20 and 20. Okay, so now when I look at this, again, I'm looking for 140. So now when I look at this, actually, let me change my colors to green. So now when I look at this, I have 80 plus 40 plus 20. When I add those 3 numbers up, I now have the 140 that I'm looking for, and it's these 3 sections. So that also means that I'm going to combine these 3 sections to identify the percentage that correlates with that. So when I add up the percentages, it's now 20 plus 30 plus 5, which is 35%. And if I divide and calculate it mathematically, that is the number that I have for my value for x. And I can check that over here as well.